All right. So this should be slide 13. I think it is. I think it's slide 13. Now, I want you to look at this sensory pathway. So we have a sensory pathway in, and then we've said we have a motor pathway out. And I want you to notice, I'd said we have first order neurons, right? So this is a first order neuron. It's coming from the muscle and it's coming in. And when you are looking at the pathway associated with the going into the spinal cord, you'll notice there is a swelling. It's called a dorsal root ganglion, and it's right there. And look at that little ball right there. That's the cell body of the neuron. So the neuron that is sensing stretch or whatever it is in this reflex pathway has a long dendrite that extends all the way in from, if this is the patellar reflex, from your leg all the way into the spinal cord, right next to the spinal cord. There's this swelling called the dorsal root ganglion. This is where sensory neurons have their cell body. And then they have an axon that extends in through the dorsal root, and it goes and it communicates in the ventral portion, in the ventral, with the neuron, with the motor neuron in the ventral side of the pathway, which is the motor neuron, and it has a cell body right there in the ventral horn. That's what I was trying to come up with. We have a dorsal horn and a ventral horn. We have an interneuron I see right here that's in between. But the motor neuron that's going to go out has its cell body in the ventral horn. So where is the sensory neuron cell body? In the dorsal root ganglion. Where is the motor neuron cell body? In the ventral horn of the pathway. And so then it has a very long axon that comes out and causes the muscle to contract. So we have this reflex arc, and I wanted to make sure and talk about where those cell bodies are with these various nerves that are in that spinal nerve. So remember, when we talk about 31 pair of spinal nerves, there are a lot of neurons inside of there, both sensory and motor, because they are what we call mixed function. They're both motor, sensory and motor. All right, so with the reflex arc, we have a receptor. We had said we have a stretch receptor here, and we had said you tapped somewhere on your body and you caused a reflex because all of a sudden you're trying to keep you from falling down, or it's a withdrawal reflex where you're burning yourself and you want to pull your hand away, whatever. You have some kind of a sensory structure. Then we have the sensory neuron, which then may or may not communicate with an interneuron. You see that one in between? There's a neuron from there to there. That's an interneuron. Sometimes the reflex arcs have them, sometimes they don't. In the simplest, you don't have them, but in many of them, they do. And then we had said, what does it do? It communicates with a motor neuron, which goes out to an effector organ. So afferent, okay, so I'm telling you something I haven't mentioned before. We have afferent neurons, and we have efferent. E, So afferent, I know it sounds silly. Afferent, they're sensory. With an E, efferent, they're motor. In between are interneurons. So the simplest reflex arc has a stretch receptor, a sensory neuron, a motor neuron, and an effector, the muscle that contracts. Okay, so moving right along to the next slide. We'd said a reflex is a quick involuntary. You don't have to think about it. It just happens. Involuntary stereotyped reaction. They tap your knee and you kick. You say, yep, it does it every time the same way. Well, that's because it's stereotyped. It's the same every time. And it can be either, the effector can either be a muscle or a gland. There's visceral reflexes as well. Okay, so for a reflex to happen, they don't happen on their own. They have to involve a stimulus. But how do you describe them? We said they're quick. They're involuntary. They occur without intent or awareness. Wow, that's a mouthful. You don't have to think about it. It just happens. And they're pretty much always the same. They're stereotyped. A withdrawal reflex is if you put your hand on the stove, before you know you got burned, you jerk your hand away. That's a withdrawal reflex. Now, you do figure it out, right? So you do figure it out, and you do get a signal to your brain, and you go, ow, that hurt, right? So in that reflex arc, you do provide feedback to your brain so that you can respond to it in a voluntary manner. Okay, so you're walking along. We have the simplest of reflexes, the withdrawal reflex. And we said you're walking along, and all of a sudden, in the case of this guy, you step on something that's cutting your foot, and you jerk your foot away. That is what happens. And it doesn't just pull it away and then stop. You have a continuous release. So we have a polysynaptic reflex that produces a sustained flexion. You go, ow, right? You pull it away and you keep it pulled away. So that's this polysynaptic reflex. So it pulls it away and maintains that flexion. Now, if it's your leg and you pull the one leg away, what's going to happen? You better extend the other one, right? And we have such a thing. We have this cross extension reflex, and that is a reflex that occurs on the other side. So we'd said, like on one side, you have withdrawal reflex. So simultaneous to that, you have an cross extension reflex that extends the other side, and hopefully you're not stepping on something sharp on that side too, because then you're in trouble. But so the cross extension reflex is where it goes over to the other side of your spinal cord, and instead of producing flexion, it's a reflex that extends the other leg. So it's so you don't fall down, right? All right. So it goes to the contralateral side. So we can read the information right here. It says the afferent nerve fibers cross from the stimulated side of the body to the contralateral side, the other side, and synapse with a neuron, and it causes the extensor muscles to extend. And so you don't fall down. All right, so you go to the doctor and they test this, right? You test these reflexes. And so what that means is sometimes they can be hyper or hypo, right? So they can be more. Sometimes you just tap the knee and you kick the heck out of the doctor. Or a lot of times in class, people say, it doesn't ever work with me, and it's because you're thinking too much. You're blocking it. But we have, you have neurons that increase the sensitivity. So excitatory postsynaptic potentials increase the sensitivity to a reflex. And then you have this other thing, the inhibitory postsynaptic potentials, that are going to decrease And that's what the doctor's looking for when they're doing this, when they're testing your reflexes. Not to see if you have nerves there. Of course you do. It's whether the reflexes are operating at the right level of sensitivity. Okay, so what is left? The rest of the slides here, we have 4 more. I'm not talking about these. These are things you have to know. So we have some nerves you need to know. So we have some nerves, a nerve that is associated with breathing. Okay, I said I wasn't going to talk about it. I'm going to talk a little bit. So the phrenic nerve emerges from C3, C4, and C5. We said we have these plexus. So these nerves are all mixed together in this network, and the phrenic nerve is what causes you to breathe. Now, what happens if you injure your spinal cord? When you get a spinal injury, you lose connection to everything below the site of the injury. Now, if you break your neck, you're probably going to die, right? And why is that? Because there isn't a whole lot above, right? You got your brain. But you need the stuff below. You need to be able to breathe, right? And so breathing is controlled by the cervical, the cervical plexus in your neck. So whatever layer you get an injury at, you lose connection to below. And that's why a broken neck often kills people. Then we keep moving down, so the lower neck, C5, 6, 7, and 8, and the first thoracic, we have these plexus that are going out, the brachial plexus that's going out to your shoulder and your arms, and so we have a bunch of muscles you need to know, a bunch of nerves you need to know. So what do you need to know from that first slide? The phrenic nerve. What does it do? It controls breathing. We then have the musculocutaneous, axillary, radial, medial, and ulnar neurons. You need to know those and what they do from the brachial plexus. Let's keep on trucking. Keep on moving on. The next page, we have the lumbar plexus. You have the obturator neuron. Make sure you know about it. And we have the tables from your book for you to look at. Then we have femoral neuron, which is going to be, so the obturator is going to your thigh muscles, and your inner thigh and your quadriceps are your femoral neuron. And so those are in the lumbar plexus. And then we get further down to the sacral plexus and coccygeal plexus, so at the very bottom of your vertebral column. And we have the sciatic nerve, make sure you know about it. And it branches into two, the tibial and the fibular. And so they're going to go on either side. It branches right at your knee. And then we have, that's all you need to know. So make sure you know, well, there will be questions about these particular nerves on exam 1. All right, so we've come to the end of today's lecture. On a beautiful snowy, it's now afternoon. I had to shovel some this morning. So anyway, I'll get this posted. It'll be probably late afternoon before you see them, but have a good day, guys, and we'll be moving on into the brain. Believe it or not, I think we're a little bit ahead. We never get ahead in these classes, except for right in this area, we get a little bit ahead, and then we have trouble staying caught up. But it's okay. So I'll talk to you later. Bye.